In this video, we're going to look at proving the following limit. The limit as x approaches 2 of the quantity 3x minus 1 equals 5. So if we're going to prove this limit, the big idea is if we are given any epsilon, can we find a delta so that the absolute value of our function, 3x minus 1, minus our limit, which is 5, is less than any epsilon, provided that we stay in an interval close enough to 2. And so we express that idea of our interval being close enough to, short enough, small enough around 2, as being 0 is less than or equal to the absolute value of the quantity x minus 2 is less than delta. So this is our scratch paper, and we're going to work with this function and this inequality involving epsilon, the function, and the limit a little bit so that we can see if we can find a value of delta of an interval around 2 such that it'll work for any epsilon that I would be given. So working with this algebraically a little bit, we have the absolute value of 3x minus 1 minus 5. We want that to be less than epsilon if 0 is less than the absolute value of x minus 2 is less than delta. Some more algebra here. Absolute value of 3x minus 6 is less than epsilon if our interval is small enough around 2, so 0 is less than absolute value of x minus 2 less than delta. Noticing I have a common factor of 3 within my absolute value of 3x minus 6. Factor out of 3. I get 3 times the absolute value of x minus 2 is less than epsilon if 0 is less than absolute value of x minus 2 is less than delta. Now at this point I notice that I've got this absolute value of x minus 2 component in my epsilon piece and this x minus 2 component in my delta piece. So what I'm going to do is now divide both sides of my inequality by 3, and I end up with x minus 2 is less than epsilon over 3 if 0 is less than absolute value of x minus 2 is less than delta. Now at this point I can make a claim about the value of delta. What I can say is that given any epsilon greater than 0, if we let delta equal epsilon over 3, then we are guaranteed, then it is guaranteed that the absolute value of 3x minus 1 minus 5 is less than epsilon, provided that we only choose x values that are a distance of delta from 2. Now let's formalize what we've done here on our scratch paper into a more formal proof. So our proof would go something like this. Given any epsilon greater than 0, let delta equal epsilon over 3. then if 0 less than absolute value of x minus 2 less than delta, that is, if we choose x values that are a distance less than delta from 2, it follows that the absolute value of our function 3x minus 1 minus its limit 5 is equal to the absolute value of 3x minus 6. Notice I'm pulling information from over here in my scratch paper. So absolute value of my function minus my limit is equal to 3x minus 6, which is equal to 3 times the absolute value of x minus 2, which is less than 3 times delta. Notice the connection here of x minus 2 less than delta. So I have 3 times x minus 2. If x minus 2 is less than delta, then 3 times x minus 2 is less than 3 times delta. And 3 times delta, well, what did we say about delta? We said that delta is epsilon over 3. So this is going to be equal to 3 times epsilon over 3, which simplifies to epsilon. Thus we have shown that the absolute value of our function 3x minus 1 minus its limit, which is 5, is less than epsilon. I hope this helps.